Hey everyone, today we're going to talk about graphs of polar equations. There's a lot of different ones. Today we're going to stick to circles and limacons. I'm going to have to break it up into several videos, so if you guys can just bear with me. Also, make sure that you have your note sheet printed out. You can copy the notes down as we go so you have it handy. The first one we're going to start with is a circle. You'll see that I already have the chart filled out, so if you want to pause the video just so you can copy down the values I have in the chart and then you can start it up again, go ahead and do that. Okay, so we have all this data in the chart. You'll see that I filled it in for you. Now I'm just going to go ahead and plot these points, okay? Now you can make the scale for R whatever you want it to be. I'm going to have each one of these be 1 for purposes of our graph, but as you see as we go, we might change it depending on the graph that we're doing. So I'll start with 4 is 0, right? That's at theta equals 0. I'm going out 4 units, so you give it an R value of 4. The next one we have there is 2 radical 3 comma pi over 6. And if we were to do 2 radical 3 in our calculator, let me just do that real quick, we end up with 3.46. So it's about 3.5. So at pi over 3, at pi over 6 rather. At pi over 6, I'm going to go out to 3.5. So I'm right about there. Okay, at pi over 3, I'm here at 2. At pi over 2, I'm back down at 0, so I'm at the pole here. Then at 2 pi over 3, that's over here. My R value is -2, which means I have to flip over the pole. So I flip over the pole and I go out 2 in this direction. At 5 pi over 6, I have to flip over the pole and go out to 3.5. And then at pi, I flip over the pole and I go out 4. So you'll see my points here. This actually is going to create a circle. And I'm not the best circle drawer, but I will do my best here. So when we graph it, we end up with what sort of looks like a circle. Like I said, I'm not the best circle drawer, but that's the general idea of what it would look like. Okay, and so let me just walk you through real quick. If we had, I think I have enough room down here, you could probably do this on your sheet as well, right? If I were to change this from polar coordinates into rectangular coordinates, right, I could I could multiply both sides by r. That would give me r squared is equal to 4r cosine theta. Okay, multiply both sides by r. Remember that r squared, I'm going to go right here. R squared is x squared plus y squared is equal to 4r cosine theta. Remember that r cosine theta is just x. So that would be x squared plus y squared is equal to 4x. And so if I move that 4x over to the other side, that gives me x squared minus 4x plus y squared is equal to 0. And now what I would have to do is complete the square. Okay, so I'm incorporating stuff that we haven't done in a while. But remember, when you complete the square, you take half of that x term and square it. So half of -4 is -2 squared is 4. And remember, whatever you add to one side of your equation, you have to add to the other. And that gives me, x minus 2 squared plus y squared is equal to 4. Okay, so that tells you that the center of your circle is at 2, 0 with a radius of 2. And you can pretty much see that from this graph here. Okay, so that's the idea behind graphing a circle. Now, there are several different situations you have with circles. The first one is when you just have r equals some number. That is a circle that is centered at the pole, and that number is just the radius of your circle. So that's the first type of circle you have. The second type of circle you have is when r is equal to some number a cosine theta. That is a circle that is symmetrical about the polar axis, and it goes through the pole. Okay. Now that a value represents the diameter of your circle, so that a value is the whole diameter of the circle. If that a value were negative, that would just flip your circle over to this side. Okay, so when you have cosine, you're symmetrical about the polar axis. Okay, when you have r is equal to a sine of theta, in that situation, your graph is symmetrical about the line theta equals pi over 2. Okay, and again, your a value is your diameter. And once again, if that a value is negative, that just flips it over and puts it down here. So you'll see in this picture there's a couple of different circles going on here. The larger red one we talked about already. Let's look at the blue circle. The blue circle is basically what we just graphed, r equals 4 cosine theta. Notice that it's symmetrical about the polar axis, and 4 is your diameter of your circle. It's on the positive side of the polar axis because that a value is positive. Okay. If you look at the green circle, the green one has r as -7, and that's why it's on the negative side of the line. Theta equals pi over 2, right? This is pi over 2 here. This is 0. This is pi. Okay? And the sign tells you that it's symmetrical about the line theta equals pi over 2. So those are different types of circles you can have. The next thing we're going to talk about are limacons. There's a bunch of different ones. I'm going to stop this video here and I'll start my new video with limacons. Thanks everybody.